Hello. So today I thought to do some problems under motion with constant acceleration. So here you should know three main equations: v equal to u plus at, v squared is equal to u squared plus 2as, s equal to ut plus half at squared. So here v stand for final speed, the final velocity. U mean initial velocity. A stand for acceleration. T stand for time. S for displacement or distance. Okay, so we'll move to the first question. The question number 1 is, you have a car. So this car is traveling with a velocity, let's say 3 meters per second. And this is traveling for 2 seconds and reaches a speed of, let's say, 9 ms minus 1. So this is our problem. The question is, of the car. This is our question. Okay, so what is the acceleration of the car? So here we say the acceleration is constant acceleration. This is our assumption. So how do you do this? We can use v equal to u plus at. The final speed of the car is 9 meters per second. The initial is 3 plus we need to find the acceleration, that is our question, and the time taken from 3 to 9 meters per second is 2. So from here 9 minus 3 is 6 equal to 2a. Therefore a equal to 3 ms minus 2. Okay, so this question is simple. We'll move to the next question. So the next question is, you have a car and this is moving with an acceleration, let's say 2 ms minus 2. Okay. The question is the time taken. You need to find the time. So let's assume here the speed is 5 ms minus 1, the initial speed, and the final speed is, say, 12 ms minus 1. So I will use this as my u and this is my v. Okay, this is how I am going to use throughout this video. The initial speed is u, final speed is v, acceleration is a. Sometimes I will use g to say if the motion is under gravity. So the question is, okay, what is the time taken, okay, for the car to change its speed from 5 to 12 meters per second if it's travel with 2 ms minus 2. So how do you do this? So I can use again v equal to u plus at, because I know what is final speed is 12, initial speed is 5, plus acceleration this time is given 2 times t is the question. So from here I can say 2t is equal to 12 minus 5. So 12 minus 5 is 7. This is our 2t. Therefore t become 3.5 seconds. Okay, so I hope you understood this problem. So we'll move to the next question. So the next question is, there is a car this is already moving at 12 meter per second. Okay, so meaning what? This is our initial speed, 12 meter per second. I'll say this is our u. So this car is brought to rest. Okay, so brought to rest over the distance of, let's say, 40 meters. Okay, so this car initially was traveling with 12 meter per second, and after 40 meter, okay, this car comes to rest. So what do you mean by this? This means the final speed of the car is 0 ms minus 1. It's 0. Okay. The question is, what is the acceleration of the car? The question is, what is the acceleration? What's the acceleration of the car? Now look at this. Can we use v equal to u plus at, this equation, to solve this problem? No. Why? Because here the distance is involved. Okay, so we don't have any term which is actually talking about distance in this equation, so I can't use this one. Okay, so what would be the best equation? So I will again recall, the one is v equal to u plus at, the other one is v squared is equal to u squared plus 2as, and the last one s equal to ut plus half a t squared. Here the question is, what's the acceleration of the car? We need to find the acceleration. So obviously I said, okay, I can't use this equation because distance is not involved in this equation, so I can cancel this one. What about this one? Can I use this one? Of course I can use this one, but then I need to use the previous equations to find the time. Okay, of course, I'm sorry, I can't even use this one, because in this case I know the final speed and the initial speed, but I have no idea what is acceleration. So this equation, even this equation, is useless. Okay, you can't use this. So only equation available is the middle one, v squared is equal to u squared plus 2as. So I'm going to use that equation. So v squared equal to u squared plus 2as. So tell me, what is v squared? The v squared is actually 0. U squared is 12 squared. And I can put a minus sign here, because you can see this is this motion is actually not acceleration, this is deceleration, right? So this is a less than 0. Acceleration is in the opposite direction. So 2 times a, what is s? S is 40. So 80 a is equal to 12 squared is 144. From here I can say a is equal to what? 144 by 80. What's the answer? 144 divided by 80. It is 1.8 ms minus 2. Okay, so this is the acceleration of the car. Okay, so we'll move to the next question. Okay. The next question is, a ball is thrown upward. Okay, so this time you throw a ball upward with 25 meter per second. So this ball goes up. Okay, so this is the trajectory. It goes up and it comes down. Okay. Okay, the first question is, when is the velocity of the ball reaches a 15 meter per second? Okay. When is the velocity of the ball, say 15 ms minus 1? Yeah. So how do you do this one? So you throw the ball with an initial speed of 25. So we know initial speed u is equal to 25. The acceleration is 10 always, or you can take 9.8. And you need to find time taken when the ball reaches this speed. Okay, so the final speed should be 15. I need to find the time taken to reach 15. So how do you do this? I can use v equal to u plus at. My final speed should be 15. Initial speed is 25. Sorry. Actually, you are throwing the ball upward. Okay, you are throwing the ball upward, but the acceleration is always in the opposite direction. So I'll put a minus sign. Minus 10 t. Right? So if you simplify this, 10t is equal to what? 25 minus 15, which is equal to 10. Therefore, t equal to 1 second. I hope you got the idea here why I put minus sign. Because you see, we throw the ball upward. Okay, so the direction of the velocity is upward. But remember, always the gravity is in the opposite direction. Gravity is always towards the ground. So that's why I put here minus sign. So the next question, the next part of the same problem, okay, the same problem, we'll move to the next part. The next part of the problem is, when is the velocity of the ball reaches minus 15 meter per second, okay? When is the velocity of the ball minus 15 ms minus 1? So how do you do this? So this time again u is given is 25, acceleration is 10, v should be this time minus 15. You need to find the time taken for this. How do you do this? Again, I'll use the same equation, v equal to u plus at. Final speed this time should be 15. Initial speed is given 25. I'll put a minus sign, okay, because the acceleration is downward but you are throwing the ball upward. So this is 10 t. Okay, so if you take this 10 t this side, it will become plus 10t is equal to minus 15, here 25, so you will get 40, right? Therefore t become 4 seconds. So what do you mean by this? This means you throw the ball in 1 second, okay, it travels let's say in 1 second it travels some distance, and the speed of the ball would be 15 meter per second. So the time taken to reach this 15 is 1 second. But this part of the question is to reach minus 15 meter per second. So meaning what? This ball actually travels upward and comes down, and at one point somewhere here it will reach the 15 but in the opposite direction. So that's why we call this as minus 15 meter per second. And you can see for the minus 15 to reach minus 15 meter per second, it takes quite longer time, because you see it has to travel this much distance. Okay, I hope you got the idea. So we'll move to the next question.